1, 2, 3 test. All right, so I'm going to continue from where I left. Yeah, sorry, that was some noise. Okay, so I'm going to continue from where I left yesterday. So yesterday, okay, I'm just going to run the notebook so we are at the same point. Then I'll explain a little bit more in detail. Okay, so I'm just rerunning the notebook. If you read the description, it will give you an overview of what happened yesterday in the previous live stream. So you have some context of what I'm actually doing now. So I'm working on a machine learning model to detect some specific animals I get in my garden. One of them is a fox. And then I get birds like everyone else. And cats. Okay. So yesterday, what I tried to do, I used the data set for training and validation, which were just using datasets that I downloaded either from Kaggle or from other sources on the internet. Okay. There were no, I didn't use any pictures that were from my own camera for training. Okay. And it from the looks of it, it didn't actually go that well. So I didn't get really good results, but I'll get to that point in a second. So I have run. So here we can see some sample images from the dataset. Some debug information. These are important for shapes, so we know we are talking about a batch of 32 images with image size of 224 pixels square and 3 channels. And we have about, for each image, we have a label. Okay. Feature batch. Didn't run this. Okay. Right. So I'll be training the model very soon. So this is doing a evaluation of the model, which hasn't been trained yet, right? We actually took we are doing transfer learning, but we didn't train anything yet, right? And this is the accuracy and the loss that you get without doing anything. Yeah. So it's the accuracy is quite low, as you would expect, because this model hasn't been trained on my own data set. Now we're going to be actually training the model, and we should get better results. So my game plan for today, we have three sets of data for testing. Sorry, for three data sets. We have the training data set, the validation data set, and the test data set. Okay, the training data set is the only data set which the machine learning model actually is going to learn from. So the machine learning model will basically look at the images and memorize them. The validation data set is used during the training to basically allow us to guide our our weights and our variables, our hyperparameters, so they can become like so we can find the better value, right? So we can adjust our weights and our hyperparameters. So that's what the validation data set is for. It kind of tells if the model is getting better or worse, and that's why you see here validation loss. Yeah. So this loss here is measured against the training data set accuracy as well, and this one here is measured against the validation data set. So even though the images here are actually not used by the machine learning model for learning, they are still used to optimize the model, right? Which means that any images that I put in this data set would, if we manage to get a good accuracy, which we get at the end, and a good, the loss you want it to be as close as possible to zero, right? And accuracy as high as possible normally. So I know, right, that this model now should have a very good. When I put the validation data set as when I test images within that data set, I know that this model is going to do very well. And that's what we're going to test here. Yeah. But, okay. So, and here you can see that the model is able to get very good predictions here, right? Cat, bird, fox, everything seems to be correct. Yeah, at least it was yesterday. Okay. And we can further actually doing the same. I can call this code again. Yeah. Just to get a proper number, right? So we can see the actual accuracy of our model against the whole of the data set of the against the whole of the validation data set. And I get some errors here. What to do? Cool. Why is this invalid syntax? I don't know. Okay, you can see loss is very low, accuracy is quite high, almost 0.98 is very good. Okay, but then we have a problem, right? When we actually run the model against images from my own camera, and that's what I'm going to do here. Okay, this is loading the test data set I gathered in the last stream. can visualize as well. So I'm going to do predictions against that test data set. Okay. And you can see this is a fox. This is a bird. Yeah, that's correct. I don't know what this one is, to be honest. I don't see anything here, but it might be that there was something on the left-hand side. But because we've cropped the images, we might have lost our subject. So that's something I need to investigate later. I don't see anything here. So I might have a problem with my data set. So it might actually need a cleanup. Or it might be that I'm cropping where I shouldn't. And that will become an issue as well. Maybe that's another reason why it's not training very well, is because the cropping is not helping. Okay, no, nothing here as well. Cat. Don't see cat, nothing. Okay, so I see foxes, right? You see it got the classification wrong. And in general, I don't blame it. For some of these ones, I don't even know what's in the picture. So, oh, here, there's something here, right? Okay, cat. Okay, so it's completely wrong. Okay, this is a visual evaluation. I can actually call this code again, and this is going to give me a number against my test data set. So I can do an evaluation test data set. Okay, so this will tell me how good the model is against the test data set. And you can see it's horrible. 0.39 accuracy. It's quite low. Right. So what I wanted to try first is to swap the validation data set that I use to train the model with the test data set that has images from my camera, right? And the idea is I'm not directly feeding my own images to the machine learning model, right? In this way, I'm not overfitting on my own images, at least hopefully. Yeah, I shouldn't be doing that, right? But my images, because at the end of the day, I'm going to deploy this machine learning model in my back garden, right? That's where I want it to perform the best, right? So I don't. But then I also have. So this should work. I think I should get better results if I use my test data set from my own camera as the validation data set. Then I'll probably have to find another way of maybe I'll create a separate test data set with images that are not in a validation data set, just to make sure there's nothing wrong there. But I can see my problem is some of these images have nothing there, and it might be because of the cropping. So I need to also probably do a cleanup of my own data set to make sure that I'm not getting the wrong answer. Because yeah, you see here, it's like cropped to the fox, right? You barely can see it. It's only. But I don't know how to solve that problem, to be honest. The only way I could fix that is by making sure that every single image in my dataset is already a square. Yeah. So this is where sometimes in the real world, right? When you're actually trying to use real data that's not perfect, then that's where you come across some problems, and we need to come up with a solution for these images which are missing. I'm pretty sure there is something there. It's just that it was cropped. But let's solve that. Yeah, I don't. Anyway, I know the results are bad. I'm going to try and improve them first by just doing the simplest, and then I'll go and do something more complicated, and I'll spend some time curating my own test data set. Okay. So I can see here the accuracy is quite bad, but anyway, that was expected that. Right. What do I do now? Okay, so now I'm going to model.fit. So this is my training data set. So I'm going to call this method to just Okay, so just adding some text, so it's easy to understand what I'm trying to do now. So I'm going to try to run this model against. So the validation dataset is going to be my test dataset. Well, this is a bit like, yeah, later on I'll make this change more permanent. Right now I'm just experimenting. I'm not sure if I need to just start from scratch again. I might have to compile the model again so that it doesn't try to use the weights. Well, why not? I can try and just continue training. So let's do that. For 10 epochs. You can see the accuracy. Wow, the accuracy is going up, which is good. Still not good enough though. Don't know why so much debug. Okay. It's not getting any better. Trying to continue the training. It's not going any higher. Okay. So I need to start from scratch again. So I'm going to compile the model so that it doesn't have the previous weights from when I actually had the validation data set and I used it during training. I think that is one of the issues. I should start from scratch. Start again. Maybe I'm doing something wrong. Okay, so dataset. From the looks of it, the model is not going anywhere. And I just don't know if it's because I'm trying to cut some corners, and sometimes that's not helpful because if something goes wrong, then you don't know what happened. It's like it's not very many images, right? Only 98. It's not enough for a validation dataset. I thought I had more. Maybe I need to put up a bit more because I have very little. Okay. Once this finished, I'm going to test something. Okay, because first of all, I want to make sure that it's the cropping that's hiding some of the subjects in the test dataset. So where is it? Here. Yeah. So I'm going to remove the setting that says crop to aspect ratio. I'll make it false. And then that means the images will actually be distorted. Uh, but that's just a quick fix just to see if this is our problem or if it's the images themselves. I need to go and review them one by one because I'm not getting good results, and this is interesting because the actual loss, the accuracy, and the validation loss and the validation accuracy are not actually getting any better. Okay, you can see that's normally not a good sign. So that means something. is wrong. Yeah, in fact, it's getting worse. Okay. And okay, so I need to make sure the quality of the data set is good enough, first of all. Okay, so I'm going to go back. I'm going to run this again. Replace the data set. And I'm going to visualize it, see if that's helped. Okay, so you see the images are distorted. I can see this is a cat. Okay, these are the predictions. Are they? Okay, these are the predictions. I need to run them this from the very beginning again. It's detecting the fox as a cat, but we can see, right, without the cropping, the actual animals are there, but they are distorted now. Okay. It actually can detect birds better than foxes. Interesting. Okay. So what do I do? I can find a better way of cropping. I could do it by hand, but that means that, okay, I only have 98 images. It's not too bad. Maybe there's a better way. This is where it can take. Okay, so accuracy is very low. Okay, so I'm going to train my model again. Without using the cropping and see if we get better results. The accuracy is lower. Not not getting anywhere. Okay, no good. The results are not good. If I'm using ImageNet, no, that's the dataset. Is it MobileNet? MobileNet V2. That's the machine learning model that I'm using as the actual base model, and then I'm doing transfer learning on top of that. And I just want to check what are the different types of input image size that he accepts, because what is it? Tensorflow Api. Okay, MobileNet. So I need to see what input sizes I can use, and I'm hoping that there is an input size which is similar to the actual input size image that is more that's coming out of my camera, which is, I think it's 1920 times 1080 pixels. Thousand eighty. I'll be back in a second. So there's a lot of mobile net models. Image feature vector. So this one, input size of 224 pixels square, which is the one I'm using. Okay, but I wanted something which is not necessarily a square. If ImageNet is just a bunch of square pictures, right? It's a bit annoying. I'm doing a lot of research now. Sorry, it's gets a little bit boring because I need to also have, like everyone else, I need to search for some information and see if there's a better way. Thanks a lot for your comment. It's a bit late for you to be watching YouTube, but I appreciate that. Yeah. Next time I'll have some soothing music so you can listen to me while you sleep. Okay. So I'm doing some research on Reddit right now. It's a good source actually of information about machine learning. I recommend you to join here. And it's sometimes when you have some questions, like it's a good place to come and search. And my problem right now is how do I deal with images which are not squares, right? And cropping doesn't always work. Center crop will crop the image indiscriminately. It might lose actually the things that you want to detect in the image. So I want to see if there's a smart way of dealing with this, or whether there's a model that I can use that already is trained on images that are not squares. So the thing about CNN implementations is that they expect squared images, but cameras, they don't give you squares normally, right? Although I could maybe do that in the future. I could force my image to be a square if it that makes it easier for me in my Raspberry Pi. Oh, I see. So there's an option here. Zero path image. Hmm. I like that idea actually. You can actually put black bars and make up the. Instead of just distorting the image, you just add some black bars, and then you can make things a square. And that's actually quite easy to do. I would do that probably. And the thing I did, right, is option two. So I tried to resize my image to be a square, and with and accepting that I would have distortion. Okay. The problem with that, well, I didn't get very good results to be honest. But I don't know if that was because I didn't have enough data, or whether it was because of the distortion. Okay, so I haven't completely ruled out this option here. I've tried it. I didn't get any good results, but this doesn't mean that's not an option, right? But I think this one is a better option. Zero path image. I just don't know how the mobile net model is going to deal with that, right? Is it going to get confused because it never saw this type of image before? Okay, this option three. Change the image crop so that any object is not cropped by its bounding box, but always by a squared box. I think that this one is saying is basically you kind of detect where the object is that you want to look at, and then you do a crop of it. But I don't think this is a good idea, because you would have to do this exact same thing also when you are well, you could create some kind of motion detection. You can do that motion detection. You can isolate your subject, then you can crop around it. I've done that, a similar thing to that before. That's also possible, but I think it's a bit more work here. And you can't just do this for the training only. You need to also have the same process during during the inferencing when you're actually using the model. And this one, obviously, I don't think this is an option, because that means I have to train a CNN with not just a few hundred images, because if you use transfer learning, it's okay to just use a few hundred images. But if you're using, but for that you need to kind of be within the constraints of the model, right? So if you So training a machine learning model from scratch, that would be a lot of more work than what I want. So let's see what people say. Okay, yeah. Oh, interesting. Um, a model that features a global average polling step should be able to adapt to the input sizes to different input sizes without issue. Hmm. I don't know about mobile net. I need to check. Let me just see. Let's find out. So we can see. Oh, can I see that much detail? Gosh. Okay. So we do have the global average polling, but that's something we added ourselves. This is the mobile net, and it's see the actual architecture here. 6 years ago, I just realized that. Right, I'm trying to figure out how to use a pre-trained model on which was trained with square images, and I'm trying to figure out how to use it using non-square images. I need to train on non-square images, so this is a bit of a challenge. Not so I'm trying to find any smart solution there on the internet. One of the options I have is to add some black bars on the image so that it can fit. I can make it into a square. The other option is to just accept distort the image, just square it anyway. That might have some other unintended consequence. Well, it doesn't work very well. I've already tried it anyway. So let's see. And I think this article is looks interesting. It's saying that you can do that for a CNN, that you can use any kind of input size of image, but I don't think it's talking about pre-trained models. Okay, let me see an example here. Getting a bit messy, right? It's possible somehow with a little bit of trickery to change the input size of a machine learning model that has been trained on square images, but I'm not sure I like going into the source code of the actual model itself. So this is what it's doing here. But this is one way. I'm suddenly liking the fact that I can just add some black bars. Okay, so I'm going to save this for future reference. How to I think I'm going to have to experiment with adding bars before I complicate things even further. So let me just have a look at the TensorFlow API. I remember seeing a method that actually does that without cropping. So there's a resize. Okay, resize with path, yeah? This is where TensorFlow comes with some goodies, right? So if I try this one, so this image, this method does what I need. But I also wanted to ideally I would do it from this method so I don't have to bother. So let me see. I mean, I can always write the code, I can go through each image and then do the resizing and the padding at the same time. But if I can do it from here as well, why not? So there's no such thing. Let me see, pad. It'd be nice to have it here, right? Okay. I think I have to write some code here to resize each image. Okay. I'm going to resize with padding. And I can start with I'm pretty sure that a lot of my training data is not just squares anyway. It's just never really, this is not square, right? So I'm going to add some squares. Well, it was, right. So as part of my copy files, I could do it here. Or after. So I can apply it to anything I want. So this is my method, the one I want to use for resizing and padding. I don't know if this is a path or... Oh, this is already a tensor. Maybe I can do that as part of the pipeline then. So instead of doing it, we see an example. If we see examples, it's actually easier. Okay, there is a method here being used. Okay, it's part of the load image. See, there's a black bars examples. I think this is exactly what I wanted to do. Okay, this is really good. This is exactly the link I wanted to find, and I'm glad. Okay, I can actually run this notebook, see how it works, and then adapt it for my own use. So this is like another example of how things can take longer than what you expect, because I wanted to just get train my model in no time, and I'm looking forward to actually make it work inside the Raspberry Pi camera. But then something as simple as the fact that my images from the camera are not square, they are things that you need to resolve first. Okay, so I'm going to run this notebook and see if, well, there is the method that I need to use there, but I also want to understand what this notebook is about. Okay. So each model has different input sizes, different settings. All of these models were trained on ImageNet. Oh, this is cool. You can actually try all kinds of models. Okay, let's try MobileNet. Oh, there's a big, small. Run against the turtle. Where's my load image? Yeah, I need to run that. So you see, this is actually cropping the image. So the image is not cropping, sorry, it's adding padding to the image, and this is exactly what I want. So let me see how I can change my code. I need to do some of these outputs so it's not so much hard work to get where I want to get to. This is for inferencing. So I want to figure out how to use this method, but with padding instead. It's okay. Late. I'm spending a lot of time now trying to figure out um, a way to. Well, the machine learning model I'm using MobileNet expects images as a square, but my camera actually is giving me non-squared images, right? And the cropping that I was doing before with this low data set from image, it was okay, but sometimes it misses the actual animal that I'm trying to detect. So just cropping images is not a good idea. So another way that to resolve the problem is to resize the image with padding instead of cropping. The method is available here, but I'm trying to figure out, because I was using this image dataset from directory method, right, which is quite handy, so we can load our whole dataset into a, into batches and then do the training. I'm just trying to figure out now how to fit this in, because I don't want to crop anymore. So I want to set cropping to false, and then I want to, yeah, I want to train the model that way. So the documentation. Not very useful, this method, unless you only want squares or cropping. So I need to find a way to do this. What do So I'm going to try an example of some code I found for resizing the image with padding. I'm not using TensorFlow because I will have to read the image to a tensor first, and then I have to apply the resizing, then I have to save it to disk again. So I'm going to try a easier solution. I'm going to use my own image for now, just one, to see how it works. Okay. So image.open. I'm just going to run it. Doesn't work. What did I do that caused it to fail? Yeah. Seems like this code doesn't work. Not on this session at least. Right, so let's see. Using OpenCV. Just want to quickly resize an image. Oh yeah, the IM show is not something I can use in a notebook. This is a tensor as well. Right, so I have an example that can add black bars to an image so it becomes a square. Now I have to save this into disk. I will create then a function that goes through all the images and adds the black bars. I am right, yeah, something like this. Okay. So I can save it here to kaggle working. Okay. And you can see, you should be able to see the image here, right? Yeah, so this is the squared image, and I just added the code here so I can make this into a method now. Okay, and I can put a file name. So I can put the path. No, I was just do it like this. Okay. Okay. Then I can put the destination as well. Yeah. So the idea I would be able to, at the same time as I copy the images, well, in this case, instead of just copying the images, I would resize them, add the padding, and then create the file in a different directory, right? So I can use this method later for, yeah, I'm going to use this instead of just doing a simple copy as I was doing before. Okay. So I'm now able, okay, so I have a small method that I can reuse. Okay. Yeah, so it does the resizing and the padding. Okay, so I have this method and I can move this to the top actually. Not very efficient this way. Since I started, I might as well go to the end. Okay. So I'm going to train with images that already have padding on it and they already have the right size. So it's just instead of just copying files from one directory to the other, I'm going to resize and pad at the same time. Yeah, much more efficient that way. And I'm going to finish my stream very soon. I'm just going to write that method, just going to test it once. And then I'm going to finish the stream and continue tomorrow or after tomorrow, whenever I have some time. Okay, so let's put it here for now. Just one more. For now, this is like temporary. Okay, this size actually can make it a default property. So for example, in this case, it's 224. Yeah. So I don't even have to specify this parameter because it already has a default value. It's quite handy. So I can just do, something like this, right? No need to show images. Just waste time. And here, instead of just copying, yeah, I'm going to comment it out. I have a, now I call the method square image with padding, and I give it the source path. Okay. Source path, and then destination path. Oops. It's not writing, I think. My keyboard is maybe needs some extra battery. Just about the time I needed this to happen. Okay. And destination path. Oh. Come on. It's almost. I'm going to spend 10 minutes just trying to type some letters because my keyboard is running out of battery. And delete, but it can't. Okay, type. All right, so I have something here. I'm going to run it. Okay. So now it's going to take probably longer because I'm not just copying from images anymore. I'm also resizing them. Okay, and we can see if it's happening or not. Yeah, it's definitely resizing it. Okay, let's see. We can see whether this is working or not because we have to view the data set anyway in the next cells. Right, so I'm going to run this here. I should see the same numbers, okay? And then now, you see actually the images are much smaller now, 224 pixels square. This one doesn't seem to require padding. It's a bit strange though. Okay, you see this one has padding. So it's working, yeah? The code is working. It's adding the padding where it's needed. And now I can always train this again. But I'm not going to do that now. I'm going to do that tomorrow. All right. I hope you enjoyed this live stream. And if you did, don't forget to click the like button. Yeah. And I'll see you again soon. Happy coding.